Here, we introduce a minimally invasive technique for the arthroscopic reduction and transosseous fixation of the elbow coronoid process fracture using high-strength suture, which represents an innovative improvement. All the authors have no conflicts of interests. Here, we have selected a Reagan-Maury type 3A coronoid process fracture of right elbow as an example to illustrate the process of our technique. The patient is placed in a supine position, the right upper limb is routinely disinfected and draped, and a sterile tourniquet is tied. The anterolateral portal is first established as the viewing portal. The anteromedial portal is prepared as the working portal, using a plasma radio frequency to carefully debride the soft tissue. The loose bone fragments are removed. Once the bone bed refreshing is complete, reduction is made to align and reposition the fracture fragments with the bone bed. An ACL tibial guide is used to determine the entry and exit points of the bone tunnel while maintaining the reduced position, and a 2 mm drill bit is used to prepare the first bone tunnel. After preparing the bone tunnel, the locator is used to continue securing the fragment, and a spinal needle loaded with high-strength suture is used to pass the suture through the bone bed and the fracture fragment sequentially. The grasper is then used to capture the suture loop, and the spinal needle is withdrawn. The same method is used to create the second bone tunnel. A spinal needle loaded with PDS traction suture is passed through the bone tunnel. The high-strength suture is then passed through the loop of the traction suture and pulled out of the joint cavity. Finally, the suture is securely tied to ensure firm fixation. After completing the knot fixation, use a probe to touch the bone fragment to see if there is any movement. Then, passively flex and extend the elbow joint and use the arthroscope again to observe if there is any displacement of the bone fragment. Postoperative imaging showed good reduction and fixation.